Good morning, everybody. I hope everybody is well rested after an interesting party yesterday. All good? So my name is Dennis. I'm your session host for this morning. And happy to introduce Matt Vlasach to the stage. He's our VP of Product and Engineering. So please,
all right.
Matt.
Thank you. All right. I got my soundtrack going too. It's great. Yeah, I hope you all had a great time last night. Those JNUC parties are really something. So thank you for braving the hours this morning and getting us out there. We will maybe kill the music though. So we'll see. Thank you, Ben. Mike. Okay, so why do we do, well, I'll wait for that 1 second. There we go. We all love the music, Coldplay. Okay, so thanks for coming. I'm really looking forward to talking about Apple's modern endpoint architecture powered by Jamf. Look, I put this presentation together and we have it like nice and early this morning because we talk a lot about manage and secure here at Apple. And the reason for that is because we're really in this big sea change when it comes to Apple's approach to security on their endpoints. The last couple of years, they've really been doing a lot of interesting innovations that takes us beyond just device management and allows them to fray into the world of security. But the reality is that evolution, you have to kind of follow the principles and the guidelines that Apple sets up, or else you're just going to be fighting against the system. We're going to talk about that this whole time. I mean, the whole thing is, if you went to the platform security session yesterday with Dan Flynn, it's a fire hose of information. There's a lot of technical stuff that's happening on those platforms. You've got vertically integrated hardware with software. It's all really secure by design. We're going to spend some time talking about that. But before we jump in, the way I thought to help visualize this kind of evolution was to kind of put our worlds at the center of the target here, center of the universe with management. So if we look at kind of how the whole world has evolved for us as Apple admins, we really have management at the beginning, at the middle. But when you look at Apple and the market in general, they started as a consumer company. Back in in the 80s or whatever, they started with an app ecosystem. They built developer tools. They allowed people to build apps way out on the perimeter of where we really are worried about from a technical management perspective. So their first WWDC was in 1987, where they started to do this. But of course, to be able to make those devices work in any sort of scaled environment, you had to have some sort of management. You just couldn't let those go for too long. I mean, they did for quite a while, but for any reasonable organization, they had to get their arms around it, whether it was an enterprise or a school. So a little company called Jamf came around, and they built a framework that was an app, basically, that did a bunch of crazy stuff on the endpoint to make it behave the way it needed to. And that was around 2002. 10 years later, you get into a world where around 2010 for iOS and 2011 for macOS, you had Apple actually bring in an MDM framework where they actually formalized the ability to manage their device without an agent just doing it itself. So it was their first time where they invested in a native management platform system that then kind of provided the foundation for management from there. Now, it was nearly a decade where everything kind of stayed that way. And you were left as administrators here trying to fill in those inner rings. You had a bunch of the security teams saying, well, I need to put stuff on here, but there wasn't really a security pattern on how to do that correctly on Macs. You had agents that were running in the kernel and causing crashes and all sorts of crazy stuff that was happening. And it was a really kind of chaotic time. Mobile is an even more dramatic story because with a sandbox operating system, you just can't even touch some of these things without falling into the patterns that Apple actually provides there. So it was this time where everyone was kind of figuring it out, and I think we were able to grow the Mac fleets significantly, but it was there was no real native pattern that kept the Macs working well. One of my favorite anecdotes is talking with a bank where they showed us we get this brand new, awesome MacBook Air that has Pro, or MacBook Pro that came out of the box. It's super fast. It's like a race car. By the time you're done putting all the agents on it, the thing operates like a 2002 iMac, one of those colored things. And it's not a big exaggeration because you have all this stuff just doing all these things, kind of fighting against the operating system to provide some of these services. But what we're starting to see over time is this evolution where Apple is like, okay, well, we're going to keep on investing into making these frameworks and these devices more manageable. So we have the introduction of DDM. And this is not necessarily in time sequence order, but this is going to make the case here. So, we see DDM, which is a more asynchronous, better, higher performant way of doing management. But then we start to see its technologies evolve into identity. We have things like manage Apple accounts, single sign-on extension, platform SSO, FIDO support, managed passkeys, these sort of capabilities that are taking in the needs of the identity organizations and baking in their frameworks and APIs into the operating system to make that work. You then have similar stuff with connectivity. Instead of low-level packet, kind of transport mechanisms that are just reading sockets raw and doing all sorts of craziness, like there's actually well-tuned and well-designed systems and frameworks that are able to give you control of packets where you need them and give you kind of protection from the kernel to be able to make all that stuff work. And those are all the sort of technologies in there. So Apple's continuing to do this. We saw relays in the last 2 years, which is probably one of the most amazing networking technologies I've seen on any platform in the last 10 years, because it's really baking in a next generation proxy into the operating system in a totally agentless way. We'll talk about that in a bit. And then this other ring, you have even more stuff for security. You have things like File Vault built right in. You have the Endpoint Security API, Gatekeeper, App Managed, we learned about a little bit yesterday. There's all these frameworks and technologies that are just, again, being baked into every shipped Mac that is in the operating system and Apple iPhone and iPad, that is being shipped to consumers. So really, that makes, when you look at this, that makes, if you use all these things, Apple's really trying to make all their endpoints secure by design. But the problem with that is that most of these capabilities are actually dormant until they're turned on. So Apple ships their operating systems with all these things. The bolded ones are the ones that are just on by default. You open your Mac, you're going to get File Vault, if you set that up. You're going to have Gatekeeper, Secure Boot, SIP, some of those other sort of things. But most of these other services that are in gray, they're not going to do anything to help you with your security outcomes unless you have some sort of service or tool that lights them up and makes them work in a way that Apple intended them to be used. So the point being, we start with this world of management, and Apple has been building out these frameworks towards these outer rings to help them and all of us achieve more secure outcomes, because really that's what's required to get these Apple devices in more prevalence in our organizations. Now, whoa. I only own the management circle. That's what I hear all the time, and it is true. We're used to that. But what I want to make sure we call out here is that these technologies are actually going to help you better position, better help your security teams with their projects in ways that they probably don't even know is possible. So I guarantee you, everyone in here has some project around digital transformation, moving stuff to the cloud, zero trust architecture, trying to get that figured out, vendor consolidation, trying to reduce the number of agents that are on endpoints, resilience, continuity, and incident readiness, making sure that these endpoints are resilient to problems and you have DR plans in place, compliance and cyber insurance. Lots of organizations need some of these functions lit up for you just to be able to get the appropriate cyber insurance from attacks. And general attack surface reduction, just trying to limit exposure to potential hacks. Now, those are all things that, again, security teams are thinking about, they want to do. And a lot of the stuff that I showed on that other slide and we'll talk about today, they're actually the building blocks to help them achieve these outcomes much more easily than they may be trying to do or that they could even think about otherwise. Now, that's all while trying to achieve your own goals. By using these platforms that are built in and leveraging the stuff that Apple's providing, you're going to have an improved user experience. You're not going to have problems with upgrades. You're going to have reduced help desk tickets because stuff is just going to work in a way that Apple's just built right into the operating system. You can maintain the tools of choice. You get to continue to use the tools that you get to help drive and work collaboratively with your security team to make those things happen. You can eliminate redundant software, and you can ultimately make it so these devices can be more trusted within your organization, so more personas can use those Macs, taking advantage of all the stuff that you've built over the last decades to be able to start with those couple personas and now be able to expand them out, especially as the price of MacBooks get a lot cheaper and more competitive to PCs. Now, this is all in a way that also aligns with some of the world's highest cybersecurity standards that are out there. So there are a ton of frameworks and reference architectures around zero trust that all of these different organizations have put together. And a lot of if you step back and look at what Apple has provided, they are actually providing a lot of the foundations to meet the guidelines that these different bodies globally are putting out to be able to make sure that those endpoints are not a weakness in an overall security architecture. And again, it's all just right there. So I'm going to spend the rest of the time kind of talking through some of the details of how what Apple's built actually can help achieve some of these outcomes. So if we start with management at the core, I don't need to spend too much time here with this group, but a couple key things to call out. Like at the end of the day, you can't secure what you can't manage is the philosophy we have here at Jamf. And it is just the foundation of Apple's modern secure architecture. You'll look at, when we go through the examples, pretty much every single thing on that diagram needs to be enabled through a management plane, because that is the way that Apple's architected their privacy model to make sure that just some random piece of software is not activating security tools. The management plane is the way that they build trust with the enterprise organization to be able to turn that stuff on. So it all begins with supply chain and procurement. I would definitely watch the session yesterday with Dan about Apple's manufacturing process, where they have a very secure manufacturing process, like down to X-ray scans, that are down to like a half a width of a human hair, all that sort of stuff, where they're making sure that there's not been compromise during the initial builds and how they actually architect a lot of that bit. That ends up with an integration with Apple Business Manager. So a lot of that trust that you're building from the development of the hardware is actually finding its way into Apple Business Manager, where you have a virtual representation that is cryptographically backed to the manufacturing process. And then that ultimately has a secure mechanism to go from ABM into device management. So if you think about supply chain, which is the very beginning place where all the security stuff could really start to go wrong, Apple has an incredibly tight, vertically integrated setup. Now then, once you're managed, of course, there's all the good stuff that we are able to do. You can track inventory and assets, OS updates, policies, certificates, service controls, all the stuff that you're very well used to with MDM and DDM to make sure that that operating system is working correctly. It is configured in a way that's compliant, and so on. Again, I will do a plug for software updates. The new DDM software update mechanism that Apple put in is much better than the previous stuff. It works very well. We've done the set it and forget stuff. If you haven't checked it out, please do. We also then have compliance. So just being able to configure an endpoint so that it has good hygiene, so that there's not known risks, just simple, easy stuff that you all can do to be able to establish that hygiene on those devices in a way that a security body and security-minded folks have said, well, these are important for us to do. We want to make that very easy for you just to be able to adhere to that guidance and keep those endpoints secure from basic exploits like not turning on file vault or not having a screensaver lock or sufficient passcode complexity. I had mentioned software updates, so that is, again, the number one thing you could do to make sure that you have a secure platform. I mean, relatively speaking, a known exploit is way worse than those unknown exploits. You can chase the stuff that may happen, but if it's already happened, you want to make sure your operating system is updated against the known problems. We're really trying to make that easy for you to get there. And one of the lesser known things, but is a really cool feature of DDM, is service controls. It allows you to go in and actually do low-level controls of applications and daemons within terminal. So if you want to be able to block sudo for certain classes of users, or you want to be able to manage the HTTPD daemon or the behavior of the shells in terminal, you could do that in a way that cannot be tampered with even if you're a root user on the endpoint. Those configurations get downloaded, stored in a read-only portion of the operating system, and then your users are able to utilize the capability there, but then they can't tamper with it either, even if they're an advanced developer. Okay, next ring out. we start looking at identity. So identity, what really is it at the end of the day in one of these modern architectures? It is high assurance, it's a high assurance identity that are critical to ensure systems know exactly who they are communicating with. And there's two types. There's a device identity and a user identity. So a device identity provides a unique verifiable representation of a device that's used to establish trust and to authenticate it. So it is a way that you're able to really understand cryptographically that this device is who it says it is. It's genuine Apple hardware and is not being spoofed along the way. Now the technology that Apple developed for this is called Managed Device Attestation. It's a platform security feature that provides hardware-based cryptographic evidence or an attestation of a device's identity in several core properties. So let's talk through how this all kind of works. It's a pretty cool process that's all baked in. And again, this just speaks to that vertically integrated nature of Apple's platform. So first, back to manufacturing. A new secure element processor is printed in a factory. It, as part of the process, emits a public key. That the private key is stored is randomly generated on the chip. It never leaves that device, but a public key is emitted as part of that manufacturing process, and it goes into a database with Apple. That chip is installed in a Mac or an iPhone or an iPad or Vision Pro, and a serial number and a UDID is associated with that public key in Apple's cloud. That device is shipped to the customer through distribution channels globally. When you power on, as we talked about earlier, Apple Business Manager will redirect you to the Device Management Service, or MDM. And then there's actually an attestation process that's able to take place, which is basically like a WebAuthn sequence where the MDM says, hey, I need you to prove who you say you actually are. You say you are this UDID. You're supposed to have a private key way in that first step that should allow you to prove that. I'm going to go the service talks in such a way that it says, hey, give me these certificates attested by Apple to prove that you actually own the private key. There's a challenge response that happens to make sure that that endpoint or that the device actually possesses that private key that was printed way over there on the left. And that allows a high assurance to take place that you know exactly who that device is. And this is all built in a vertically integrated service. Again, this is hardware, this is software, this is DDM and MDM, and this is an Apple Cloud service and a PKI infrastructure that's all just kind of magically working behind the scenes for you to make this endpoint secure. So some of the benefits of Managed Device Attestation more generally, again, those private keys are hardware bound. They can't leave the device. There's no way you can get to them. There's no known exploit. It's its own separate processor with its own separate operating system that's running the key calculation processes. Makes it, again, no known exploit. You can exploit iOS or macOS. It can't get to the private keys. They're also not accessible by the user, of course, in any way. You get some properties through the Managed Device Attestation process, like is Secure Boot enabled as part of this process? Has system integrity protection been turned off by the user? You actually get that back in a cryptographically signed certificate that you could use in smart groups or other sort of services to say, well, something's happened on this device. I don't trust the MDM protocol in that case for some of those really low-level things. I'm getting a certificate from Apple that's telling me that this is the case. So it's really a profound evolution of how much of zero trust and how you're able to trust the data coming back from the device. And it's usable in client certificates via ACME. And I want to kind of talk about a really cool capability with certificates today that I'm seeing a lot of excitement and opportunity around. Wi-Fi and Ethernet. It is one of those things you just have to do to get your devices connected to the internet, to your network, to be productive. A lot of organizations will use certificate-based 802.1x for both Wi-Fi and for Ethernet. The hoops required to go through setting up a certificate just to get that device to connect to Wi-Fi is unbelievable. Like, you're creating proxies, you're doing all this exchange of keys, like there's all sorts of craziness happening. But Apple's made it a heck of a lot easier, and it's using an ACME device, the ACME protocol with device attestation. And what it allows you to do is spin up a certificate authority that uses this device attestation principle so that you remove all this inherent trust and a lot of the stuff that you have to do along the way to make this happen. So how does this kind of work? So what happens is, again, through the device management service, you provision an ACME certificate, not too much unlike a SCEP certificate. What that does is it sends an ACME, the device sends an ACME certificate request to the back end. Now, what ends up happening is a sequence that involves Apple services there, you see there. There's the device attestation validation where the device actually sends a attestation certificate in that request that came from Apple. The ACME CA validates that attestation is genuinely from Apple, and then it will go ahead and it will issue back a certificate. One other step it will do is it'll actually look at those properties within like that certificate, like from Apple. One of the OIDs in there is like, what is the UDID or serial number? There are integrations from some of the vendors out there that will actually go and like check with Jamf Pro to make sure that that device serial number is actually enrolled in your environment. So you're not trusting some secret that went through successfully or any sort of implicit trust. You are verifying that that UDID that is in that certificate from Apple is actually present in your MDM. And only if that happens, it will then go ahead and issue a certificate to the device. And then that certificate can be used for 802.1x, both for Wi-Fi as well as for Ethernet, where your cloud radius or your radius server is able to trust the PKI, just like you always have with that certificate, to be able to allow that device on there. So you have no SCEP, you have no ADCS, you have no secrets, no dynamic or static secrets involved, and just no complexity. If you do this all with a cloud provider where you're just trusting the attestation cryptography that happens throughout the flow, so many steps can be removed, but yet you end up with an even higher security bar because there's no implicit trust anywhere along the way. So, what else is pretty cool, and Dan talked about it a little bit yesterday, was you could actually take device attestation into your actual applications. So getting you online, great, you're now on Wi-Fi or Ethernet. What about your application? If it wants to do secure communications with your server, you want to do some signing and everything like that, traditionally there hasn't been a way from an MDM to give your apps, your trusted apps, a certificate. You had to go through all sorts of hoops or do some really insecure things to kind of make that work. So the Managed App Framework actually allows you to deliver a certificate, like an ACME cert with device attestation, right into your application. And so what happens is that whole process happens, and your app has exclusive access to that certificate to be used for secure communications with your servers. It is something that's been in the works for like probably 10 years, I think, over at Apple, because it's so hard to get this right from a cryptographic and security perspective. But it is awesome because it really will change the game of how you could secure your managed apps. And it's actually very, very easy to get this to work. So when you define a DDM asset, you define an ACME certificate, for instance, and then in the top, that's what you do there with that asset. Then you configure an app managed DDM configuration. Within that configuration, there's a reference to the asset that is there. So you simply reference the ACME asset there and push that down to the devices. And then what ends up happening is your app in Swift is able to, in a few lines of code, access that identity in a way that your developers are like, yep, that's a cert. I know exactly how to work with this. And Apple provides all of the necessary signing and other sort of services that are required to help you leverage that certificate for effective communications with your services. Okay, so that was just the device identity. User identity is a unique digital representation of a user that enables authentication, authorization, and access within a system. Now, when it comes to identity, we all very much know passwords. That has been at the center of our existence for a very, very long time. It is and continues to be a big part of macOS and other platforms. But in the modern architecture, that's not really there. It is a phishable factor. I mean, I could tell you that password, and that factor is now dead. It's not an effective multi-factor. And we're seeing an incredible increase of phishing attacks and other sort of like multi-factor attacks where if I can trick you to give me my password, I can actually trick you to give me my one-time code or some other form that can allow you then to like log in on an untrusted device. So we're really trying to get away from passwords as an industry as a whole. They're just bad when you really take a look at what they are. And so working towards a world that looks a lot more like passkeys. So we're trying to evolve to passkeys, where those passkeys are basically, think of them as like a digital representation of a password, but you can't read them, you can't share them. They're kind of bound to a device or at least a cloud account in some cases. But what Apple's provided is something called managed passkeys. It's not a very well-known feature. It's bound to manage Apple accounts, but the idea is that you can make sure that a passkey that is issued by your IDP or some service issuer lands in the managed Apple account keychain, that it can never end up in the personal keychain. It can only end up in the managed Apple account, Apple iCloud keychain. And that gives you the ability to do some really interesting things and have that efficiency of being able to share a passkey across devices or managed devices that allows you to get in there without having a lot of the risks of passwords in an MFA. Of course, this is in lieu or next to a lot of your IDP-based authentication, which we'll talk about here in a second. And the experience is awesome. I mean, if you go to something that needs a passkey or a managed passkey, you go there, you're probably seeing more and more of this in your day-to-day as you start to leverage passkeys with services like Google, GitHub, so on. You just get this great little pop-up, and on the Mac, it's a nice little Touch ID, and this is infinitely more secure than a password with multi-factor auth. Now, the other mechanism I was talking about is with your IDP, so using an identity provider to be able to provide you efficient access into the system. Now, Apple's built a framework called the Single Sign-On Extension, Extensible SSO, which includes what's called a Single Sign-On Extension that an IDP provider builds within their application. So what happens is the MDM will send a configuration profile that basically lights up this extension. It authorizes it to be used. Again, back to my point, like this stuff doesn't work without device management at the core, right? So you have that configuration that's being sent, and then what ends up happening is phishing-resistant authentication to your apps and services. Now, I'm sure a lot of you are using this already, but I figured I'd throw the video in. Like, it's a really great experience for end users too. You just go in, you try to go access something, it pops up. That was the secure sign-on extension, and it's popping up that Okta had built. Fingerprint in. Similar for iOS and iPadOS and even VisionOS. In this case, I'm just going to pick Okta FastPass. That graying out and then that little check mark is actually the single sign-on extension UX that is invisible on an iPad or iPhone, where you just keep on looking at your phone and it goes through. So you have this excellent experience of being able to log in more efficiently, but it's also far, far, far more secure than any sort of password management system you could have. All right, so that's logging into apps. Now, all the rage this week is around platform user identity. So Apple started with that single sign-on extension because, again, they're trying to get away from phishing-resistant credentials to log into your applications. Because you think about your attack surface, you just don't want passwords floating around to log into your sensitive applications. So it made sense for them to start with a world with those IDPs to make it so you get a really easy log in there. What Apple's been doing is they're now taking that backwards all the way through the device login to unlock your machine, and then even now to enrollment. And that's all through their platform SSO architecture. And what we're basically doing here is we're taking this idea that the moment you unlock or unbox your device, we're going to establish strong phishing-resistant identity on that device for you as a user, but also establish identity for the device that can flow through that entire experience. So we'll talk about how that's going to work here in a second. So back to how this all kind of works from a high level, you basically power on that device. Your ABM directs you to the necessary, your organization's device management service. But now what's happening is we're invoking platform single sign-on with simplified setup right out of the box at the very beginning of this whole process. And as you probably saw in many sessions this week, single sign-on for Mac is this kind of captive blocking interface that gets you through the whole process of logging yourself into this machine with verified multi-factor credentials. So what does this kind of look like a little bit underneath the hood? So within this platform SSO realm, you once again the first thing that happens with platform SSO is that the IDP is actually registering the device with its services. You think about an IDP as a user registration service, but actually the IDPs are now really focused on understanding exactly who that device is. And they're now using device attestation to be able to get that same certificate I talked about earlier to verify that hardware that they're activating and that they're logging in with at this step is, again, that cryptographically certified endpoint that Apple says it's supposed to be. So they're using that for an initial device registration point. And that is being shipped over to the identity provider. Now, quick little call out. if you're kind of following all this. What's really neat is now you have two separate entities. You have your IDP and your device management service. They've each independently got to a device attestation certificate, which should exactly match. If they don't, something's gone wrong. But you have independent processes where you've been able to get cryptographically backed identifiers that you can use not only during this initial onboarding process, but later throughout the whole life cycle of the device that involves the device and the user doing things. You're able to validate that those entities are actually matching. And that's a really big deal because up until now it's all been just kind of like, yeah, it's mostly going to work out. But this is actually cryptographically backed, which is core to a true zero trust architecture. So then during this user authentication process, you're able to do MFA and FIDO. So again, username, password, one-time token. One of the things I've seen the IDPs start to do is like a verified ID. If you're used to Clear, where you hold up your phone and it's like scans your face for liveness, you put in a passport information or other like state identification. That could be how you do your first device enrollment. There's some really cool stuff around that. So you kind of solves that first password problem. But then also if you have a FIDO key or other pass key, you're able to use that for that initial authentication. So as part of that process, there's two methods for platform single sign-on. One is a password sync, the other is an enclave back key. I believe the enclave back key is the way of the future because you have no passwords to worry about in that case. You are actually using a cryptographically backed and human non-readable credential that you're using to log into all of your cloud services. So what is this secure enclave back key? Now, I gotta admit, when I first saw this, I'm like, what is this thing? This makes no sense. I don't understand. How could a key that is on the device represent the user? And what you're basically doing is it is storing a key that represents the user that is then unlocked by a local knowledge factor on the device. So what that means is that I have to have physical possession of the device and either use my Face ID or Touch ID or a PIN to be able to unlock this credential that represents me on that device. I can't move that credential to any other service. It's locked to that device. So an attacker somewhere in another country or another location that doesn't have physical access to that device could never get my private key with a secure enclave back key. So the key thing with it is that for all sorts of design reasons, you still have to have a local password on the macOS device. This is not passwordless. So you still have to have something to unlock file vaults, and ultimately you could actually even use it to unlock that local key. But it doesn't have to be the same password that you have with your corporate identity. It could be more of a PIN or a passphrase, something that's a little different. But the key thing is that secure enclave back key is unlocked with Touch ID or password. So how does this flow kind of work from there? So you now have this, what happens is you build a private public key pair, and this is simplifying some things, but for all intent and purpose, you have a private key that's now, it's entangled with that secure element on the device that can never leave. So that private key is stuck on the device, no one can get rid of it. What you do is you register the public key with your identity provider during this SSO setup. So now you have this digital representation of the user in the IDP. Now, when you want to log into an application or you unlock your Mac, the first thing you do is unlock your Mac with your Touch ID or with your passcode. What that actually does is it goes out and it will go using that public key. It will go out and it will talk to the identity provider. There will be a challenge and response process where it checks to verify that you actually own that private key, similar to some of the processes we talked before. And now when you go and you log into applications, you actually have a key that can log you into your apps. And this all happens just completely transparently to the end user. It just works. And again, it's just a magical part of the platform that is kind of coming together to make a more secure outcome with a great user experience. Now, some organizations, they don't want it so you can just have a passcode or a PIN that just unlocks the ability to get into sensitive resources. So what you're able to actually do is you're able to actually have the identity provider challenge you for another factor. So what happens is we're able to send a login request to the IDP. It can come back and say, hey, in order for you to actually get into the sensitive app, I need you to actually prove your biometrics. Now, Okta versus Entra do it in slightly different ways today, but it's the same idea. In order to get to that sensitive app, you have to prove your presence with a previously registered biometric, whether that's Touch ID or Face ID. A PIN or passcode will not work, because those are phishing-resistant credentials. And again, Apple's built this all right into their frameworks. And that allows you, ultimately, to get in. Another core function of the platform, manage Apple accounts. Apple's been talking about, formerly known as Managed Apple IDs and MAIDs. Managed Apple accounts is the new term for it. The whole idea, like as you look towards where Apple's headed with identity, Managed Apple accounts are going to be the thing that Apple uses to bring more cloud-oriented services that revolve around the corporate identity, that need authentication with your corporate identity. They're going to be all delivered through Managed Apple accounts. So how do they generally work? What you do is you federate your organization's IDP with Apple Business Manager. So there's a federation process, a domain reclaim. We don't have enough time to go through all that today, but it's definitely something you'll want to do. But you basically make it so in order to authenticate to a Managed Apple account, you're actually using your IDP. So users don't have another username and password for a Managed Apple ID. It's just being logged in with your corporate credentials. The users don't really know any difference. Now, there's a couple cool things that Apple's introduced. Like you're able to now have some Apple account login policies that say where you could use these Managed Apple accounts and on which devices. So specifically, you've got Managed Apple accounts where you have a device usage policy on what devices you are allowed to use these components on, or these Managed Apple accounts on. And you also have a policy that says that you can only log in, this is a new one. You could say that on my managed devices, I will only allow a Managed Apple account to log in. So no personal Apple accounts on my corporate-owned device. That's a really big deal. A lot of organizations have been asking for that for a very long time because, for DLP purposes, and Apple's finally got Managed Apple accounts to a point where you have some things like continuity and other sort of stuff so that you have enough of an experience with a Managed Apple account between your Mac and your iPhone, for instance, to be in that ecosystem. It's very cool. Now, tons and tons of sessions about that this week, so I'll take a second for you to take a picture if you want to do this. These are things to rewatch if you didn't catch them earlier. There are just lots of great sessions about PSSO this week. We also are managing a guide, jamf.it/PSSO. It is actively being worked on and will be updated as we work with our identity provider partners to be able to add more services and capabilities to light all this up. Okay. Wow, I've got a lot to catch up on here. So, connectivity. That was a big one, though. Seamless access to specific apps that users need on any internet connection anywhere. What good is an Apple device if it can't connect to the stuff you need it to do? And by the way, Apple users expect stuff to just work all the time. That's the way they're conditioned with school, with their personal lives. They open an app, it just works. They want that to be the experience with the Mac. They don't want to have to fuss with a bunch of VPNs and all that sort of stuff. It needs to be seamless to any apps on any internet connection from anywhere. Now, there's kind of two parts to this, and there's one part I want to really call out, which is on the mobile side when it comes to cellular. There's some really cool technologies, again, baked into the operating system, not usually talked about because they're so focused on enterprise that I want to make sure you guys are all aware of. The first is eSIM. You're able to land cellular services down to the device through MDM. So MDM can push a configuration profile that can bootstrap a eSIM that is for that user, for their region. There are some SIMs that are global in nature, but you're able to get that high-performance global 5G connectivity just right out of the box. And you can use existing carriers, and there's a lot of other carriers that provide this service, and it's bound to management. That device leaves management, that carrier subscription goes away, you're not paying for that cellular service anymore. The other thing that's really cool is what's called 5G slicing. So typically with cellular networks, that last mile, you've probably all experienced this if you go to a ball game. You may have 5 bars of signal, but man, it sucks. It's super slow. It's like nothing's working. And it's not because the signal's not strong. It's because the spectrum is completely overwhelmed. There's not enough bandwidth within the spectrum. There's too much noise from all the devices in there to actually do anything. So a lot of the carriers are introducing something called a private band. That's for enterprise. It's through 5G slicing. So if you have mission critical functions that have to happen over on that device, or for a specific device, you can get dedicated spectrum that will not be interfered with by the rest of the people going on. So we see this like if you're an aviation company or an airline, you need to make sure your phones are able to communicate very effectively with your services, or else you're delaying planes if there's an event or there's oversubscription on the network. Now, app level 5G slicing takes it one step further. It says, I don't want to give priority to all apps on the phone. I want to give priority just to specific apps on the phone. I have that airline booking app. I want that to have priority. I don't want to pay for that attendant to watch YouTube over this premium signal. So you could really get nailed down here. It's pretty awesome how that all works. So you now have your Wi-Fi, Ethernet, and cellular all taken care of. You have this really effective connectivity that's attested at the lower layers of the stack. Now, how do I get to my apps? How do I actually make this all work? We're used to VPNs, we're used to MPLS networks, we're used to all these other sort of things that like just you have to be in a certain condition or do certain things to make that happen. Network relays change all of that. It makes it so that no matter what network you're on, you have this device level connection for specific apps or the entire device over any network connection that just is providing this kind of zero trust connectivity over any network without any agent or any user interaction. And what happens is, Jamf offers a service for this. The relay function is something that Apple provides native to the operating system. We provide an actual service that is able to utilize that, and the whole idea is if you're using the Jamf platform, we just want to get networking stuff and problems and connectivity challenges out of the way. And we provide connectivity through cloud-sourced IPs, so we will egress out of our data centers using a cloud IP that belongs to your organization or is shared to get to SaaS resources, or you could set up an IPsec tunnel between a private cloud or so on. Now, this, I don't have that. Oh, yeah, a couple things. Zero touch and agentless, meaning no app is installed for this. It's in the operating system. It's incredible. It makes all the difference in the world. There's no app to install, no app to worry about, and there's no app for the user to open to have to authenticate in to get this all working. It just works. It's ultra fast. It's using Quick, HTTP3, super modern tunneling protocol to make all this work. It's the same thing that iCloud Private Relay uses for their consumer service. It's FIPS compliance cryptography. It's TLS. It's same thing that's used for HTTP. It's well accepted by a lot of standards bodies. And it's using that Managed Device Attestation for the client certificate. So that means that you're not subject to any adversary in the middle attacks. It's all very, very well secured. Now, that gets you this incredible device level attested connection you could use as a layered security approach. So what I see a lot, and I recommend a lot of times, is, hey, just put your IDP traffic through a relay. It makes it so anyone who's on the network can't just intercept it or spoof or understand that you use Okta or you use Entra or try to get in the way of and try to exploit that connectivity. It just gets wrapped in this invisibly impenetrable tunnel that traffic cannot be monitored. Now, this works in conjunction with your VPN. The movement to relays, you could use a relay for your entire ZTNA strategy or just for some connectivity. But we see this being an evolution away from VPN to relays. So the services are designed to work well together to help you with that transition. Okay. Oh yeah, one more thing here. On-device content filter and DNS over HTTPS, other built-in capabilities that make it so you're able to provide content filtering, phishing resistance, DNS protection, all baked in, enabled by MDM. Almost done. Yeah. Last ring, security. Protecting the endpoint from malicious software, enhancing visibility, and responding to threats. Now, as you learned yesterday, or if you will go watch the session, Apple has a ton of built-in functionality just out of the box, again, that keeps the operating system super secure and just prevents malicious apps from running in a lot of cases. But it's not impenetrable. So even Apple will say, go ahead and install other agents that are necessary to help your security team gain confidence in that platform. Now, at Jamf, we really believe that you should be making sure you deploy the agents that your organization's using on your PCs, because a lot of them have come around to use these modern endpoint APIs, and it helps legitimize Macs within your security teams that if they are able to see a Mac show up just as well as a PC, that's great for the growth of Apple. And we push and we work with these vendors to make sure their applications are able to install really seamlessly and effectively. We also recommend, our EDR agent because we look for specific threats that specific Apple threats that these other guys don't necessarily look for because they're covering such a broad span of capabilities. We fill in a lot of gaps. We also look to making sure that we're able to work with those different partners that to adopt something called shared signals framework, which allows those vendors to send signals to other ecosystem providers to take action upon a Mac if something goes wrong. So for instance, say CrowdStrike detects something bad or Jamf detects something bad, that could get signaled to Zscaler, who can then block access to those resources. And this is an open standard being used for that. There's a session we did yesterday on that if you're interested on this some more. Telemetry is also the biggest missing piece I think we see in security. Those EDRs do a great job of covering the broad bases, but having something that your security team can have from their Macs just give visibility directly into their SIEM, I can't say it enough. They love that stuff. They love having the data to build dashboards, and a Mac being able to show up in there and show exposures that they didn't even know existed or they didn't even think it was possible on a Mac. They love it. So that is something that is unique to our Jamf agent that coexists very well with other EDRs. And there is a ton of data that can go on there. The last kind of build I'm going to do here is when it comes to that telemetry data, showing when the system booted, that a user logged in at a certain time, a unencrypted USB stick was plugged into that device. Hey, we saw a malicious script that was run. That user then elevated to admin. So a sudo command was executed. A suspicious curl command was executed. All of these different kind of events are happening on that device, and they're getting lost in gigabytes worth of data every single day. We're able to package up the most important events, send that over to your organization's SIEM, and then they are able to utilize that to do an incident response, have an audit trail, and do what they need to do. Okay. I'm going to bring this home. Thank you for the extra time, guys. So really, in summary, Apple's modern architecture is a direct result of their vertically integrated platform. They have hardware and software that has far fewer combinations than anything you'll have in the Windows and PC world. So they're able to take shortcuts and take opinionated design patterns that you just can't get with another platform. It allows you to both manage and secure Apple devices through your management plane. And I kind of liken it to driving a car versus where we're headed with autonomous vehicles and whatnot. Windows and the PC architecture, it's secure by configuration. There's so many options and so many different ways to have hardware and software and peripherals. You have to configure your way to security versus secure by design, where it comes out of the box secure, and it will stay secure as long as you play along with the frameworks and the rules that Apple's laid out. And that is exactly what we're trying to do, and I think where Apple is going to continue to evolve the roadmap to make it so you can just sit back and enjoy the ride. Thank you. That's it. All right. I don't think we have time for questions, do we? Maybe up here if you want to ask any questions.
Yeah, thanks so much. I think there is a lot of room for questions after the session, maybe.
Perfect, yeah.
Yeah, so thank you all for your time, and on to the next one, I think.
Yeah, I'll be up here for a little bit. Thank you.
All right.